Hello, I'm Jack. This video is to show you how to use CGO2 to process our static data. CGO2 is a CHC design software. It has it has several powerful functions, and the most important function is GNSS model, which used to process static data. So let's start. Double click CGO2. Like all softwares, the first step is to create a new project. The name will automatically generate it based on the date. Here we can choose the directory. I choose Jax and confirm and confirm. So now the project is already created. Here is the toolbar. You can see GNSS model. This is we used today. The first thing is to import static data. So click import, and you can see CGO training, KN data, raw static data, and import all this. Click OK. So here it will import all observation fields to this software. And we can have a look for our data today. So this data is from Kenya, and here is some information about the coordinate system. You can see this here lists all base stations and the recording time, start time, over time, date, antenna hits, and as the number of receiver. And here shows the control point coordinates. Here are 3 known points, and this is the information about ellipsoids, CRS, and relative parameters. All of those information we already know, so we can start our project. Oh, this one. Oh, no, this one. Okay, here, when we import all fields, click confirm. It will pop up a box. It said attention, have a same name station, distance of field name, modify name as. Here we click remember my selection and confirm, because we can correct the information later manually. Click confirm. It pop up another box which said the difference between the coordinate and the current project central meridian is large. Whether to modify. So this means we need to modify the central meridian. Click modify, and it will pop up the property information. This is the basic information of the project. The zone we need to convert it later, modify it later. And this, if your country is located in north, here choose north, but if your country is located in south, click south. And you can edit your name here. And let's go to the coordinate system. The first thing we need to choose the correct coordinate system name. You can see here it's only 184. So, but our coordinate, our ellipsoid is Clark. So we need to add a new one. I already create a custom, so let me delete this one. Okay, custom, we can click new to create a new coordinate system. And first we need to select the correct ellipsoid name. Or ellipsoid is Clark 1880, Clark 1880. It will show the relative parameters. Need to confirm with the or Excel table. So I think it's correct. And click projection, we need to choose the projection method. So this projection is transverse Mercator projection. So choose Mercator projection. Oh no, not this one. And here is a central meridian. So this data, the central meridian is 39. So click here and change to 39. And the orange latitude is 0, and the scale factor is 996. Scale factor is 0.996. And the force easting is 500,000 correct. And the force northing is 10 million. Here's 10 million. Correct. And these two just keep default. Datum transform and plan calibration just keep default. Click save. That is our custom coordinate system. Click select. Okay, here it will become custom, which is our coordinate, and it's ellipsoid. All information are correct now, and click confirm. So now you can see the list. Here are the observation fields of our base data. So the next step, we need to edit the antenna height based on the start time and end time to compare with this table to find which one is corresponding to the station. But maybe you will notice the start time is different with our list. That is because we didn't change the GPS time mode. So if you want to change GPS time mode, click configuration. As here GPS time mode, we choose local time. Because this data is from Kenya, so I think it's for UTC. Confirm. Oh no, it's 3. Alright, it's 3. Confirm. And you can see, and now the time should correct. We can choose the first as example. So this data, the start time is 15:30 and the end time is 16:41. We need to find this time based on our list, based on our Excel table. As here, the start time is 15:30 and overtime is 16:40. Sometimes it will have a difference between 1 or 2 minutes. It's okay. You can see the SN number is 7957, and this station is also 7957. So the first file is corresponding to the GFLU station, and now we can change the information of this one. First, we need to change the station. This is GF6, and keep the receiver as default. And we need to add the antenna height. So the ladder to this is central bumper, and the antenna height is 1.476. Antenna is 1.4476. And the manufacturer, this receive this data from CHC, and the antenna type is P5. That's all. Keep other parameters as default. When you change ready for the parameters, click confirm. You can see the station name already changed and the antenna height is also added here. And now we need to change the second field. Second field starts from 1338. So 1338, 1338, 1340, 2 minutes difference is okay. And the end time is 1516. Okay, I see here 1516. So the second field is corresponding to G2 station. And now we can change this one. The station name changed to G2. And the antenna, we need to change the antenna height. The G2 is 1.447, 1.447, and we also need to change this one, CHC Navigation P5. So up to now you can see actually the antenna information are both same except the antenna height, but the other manufacturing antenna type are all same among these observation fields. So we can choose a simple one. As here, application options, application range. We can click all fields and click antenna type to make all fields have a same antenna type. Click confirm. And you can check on the third field. You see, the manufacturer and the antenna type are default now. The fourth one also default. So what we need to do is change the station name and the antenna height. So we need to modify all fields and add the antenna height of these fields. So it's very slow, so I already added a new one. Clear the information. Can see here? I already added all antenna height of the fields. After all observation fields already modified, we can process all data. We can process the baseline. Here is the process baseline. Click process. The software will start work. We can see the result. We can see the baseline results later. Okay, it's finished. Click baseline. This is all data. Because this data quality is good, so all baselines are success, are qualified as conformity. But in generally, maybe you will see some unconformity of the baseline. So if you face the unconformity, we need to modify this baseline manually. For example, other thing is you can see here is the ratio and the RMS. These two reference the quality of the baseline. The ratio value should above 1.8 and the RMS value should above 0.004. So for example, if this baseline is unconformity, what we need to do. So, for example, right click and click the residual sequence diagram. Click this one. It will show the satellite quality, the signal quality of each satellite. The G reference the GPS satellite, and the R reference GLONASS satellite, and the C reference BeiDou satellite, and there is no Galileo data. The Galileo satellite is start with E, means Europe. That's it. And we can click. This is the GPS satellite signal, one of GPS satellite. This wave is very, the data quality is not good. It has a huge wave. And click next, you can change another satellite. So sometimes if your ratio is under than 1.8, the baseline should become unconformity. So now you need to unselect some bad quality signal. For example, the G18. This satellite signal is not complete. It's missing a lot of data here. So we can unselect this data and to process again. See, the ratio has a little improvement, but it's still very low. We can find another one. Generally, the GPS satellite signal is good. The big problem is caused here. Only a little data of this satellite, and this satellite is also change very vividly. And go to this one, we need to unselect it and click process. See, the ratio already become to 99, so the baseline must conformity now. That's the method how to increase the ratio and change the baseline to conformity. The detailed steps you can see another videos. It will introduce more details. And up to now, all our baseline are conformity. So the next step, we need to adjust to get the reports. Before we adjust the reports, we need to import our known point to make a compare. So you can click station. Here the station is our base station, all base stations of this project. See, our known point is GF9, GF6, and R3. Here we can choose 2 points as control point and leave the last 1 point to compare the result to see the quality of adjust. Here we can choose the last one as control point. The first is GF6. Find GF6, the first one, right click. Here is the convert to control point. Click convert to control point. There will be simple here. Other one is R3. Right click R3, convert to control point. So now these 2 points already convert. You can find these two here. So because these 2 points are known points, so we need to edit the coordinate value manually. So copy this and change here. Click the first one and here choose NEH and the north paste and the Y paste and the height control height point and click confirm. Now this control point has a correct coordinate information. Let's change another one. Here leave as NUH and click copy and paste. Copy and paste. And the last one hit and confirm. Up to now, all two control points already modified, and you can already control point. And now we can go to adjust mode to get a network adjustment result. Click adjust. Generally, there are 4 functions we can choose. Generally, we will choose the first one and the last one. The last one means there are at least 2 local constraint control points. Because for this data, we have 2, so we can choose here and click adjust. And now is the report. You can click here to check the result. Can look this model coordinate change. The difference is 0.001 meters. These are the final results what we want to get. Because this data is just the sample data, so we don't do a very precise baseline process. So here the height is a little large, but the function, the method for how to process baselines are same. And that's the all processing that's the all process of how to use GNSS to process static data. Thank you for watching.